Hi, this is Alex from devstories.eu. MicroPython, Episode 6 of 7. You upload a perfectly valid Python file to your microcontroller, type import, and the board instantly crashes with an out-of-memory error. The code itself is fine, but the process of loading it just consumed all your available memory. Fixing this requires bypassing the on-device compiler, which brings us to compiled versus frozen code for production deployments. When you run a standard Python script on a desktop, memory is practically infinite. On a microcontroller, memory is strictly constrained. When you drop a standard Python source file onto your device and run the import command, MicroPython does not just read the file. The compiler fires up right there on the microcontroller. It parses the text, builds an abstract syntax tree, and generates bytecode. Every single one of those steps allocates memory and RAM. Consider a large IoT framework that handles networking, security, and sensor data. If you try to import this massive module from a standard source file, the compiler will likely exhaust the available heap memory before the first line of your actual application ever executes. The spike in RAM usage during the compilation phase kills the process. To bypass this, you need to remove the compilation step from the microcontroller. You do this by pre-compiling your code using a desktop tool called the cross compiler, or MPY-cross. You run this tool on your main computer. It ingests your Python source file and outputs a compiled file with an MPY extension. This file contains the pre-generated bytecode. When you transfer this compiled file to the microcontroller and import it, MicroPython recognizes the format and skips the compilation phase entirely. You completely avoid the memory spike caused by the compiler. This is where it gets interesting. While pre-compiling saves you from the compilation memory spike, the microcontroller still loads the actual bytecode from the file system into RAM in order to execute it. If your IoT framework is large enough, the bytecode alone will still consume too much RAM, leaving you with very little space for your application variables and data. When pre-compiled files are not enough, the final step is freezing the bytecode. Freezing means baking the compiled code directly into the MicroPython firmware. Instead of copying the compiled file to the file system of the board, you place it into a specific modules directory within the MicroPython source code on your computer. You then rebuild the entire MicroPython firmware image from scratch and flash this custom firmware onto your board. This changes exactly how the code is executed. When you import a frozen module, MicroPython does not copy the bytecode into RAM at all. Because the code is baked into the firmware, it permanently resides in the microcontroller's flash memory. MicroPython executes the bytecode directly from flash. By executing from flash, the RAM footprint of importing that massive IoT framework drops to nearly zero. All of your RAM remains entirely free for processing real-time data. The fundamental difference comes down to where your code lives while it runs. Pre-compiling saves memory during the import step, but freezing saves memory for the entire life of the program by forcing execution to happen entirely in flash memory. If you would like to help support the show, you can search for devstories.eu on Patreon. That is all for this one. Thanks for listening, and keep building.